In Linda's lab, her staff regularly have to determine the accurate mass of various samples. Linda knows that when purchasing a new balance or set of balances for her lab, a number of factors must be considered. One of the first things to consider is the capacity of the balance. Generally, the capacity of lab balances range from 1 gram to a couple of kilos. Knowing your typical sample weight will help you select the best balance. Make certain that your balance has sufficient capacity. There is little sense in having a balance that can't accommodate your largest samples. Instead, select a balance with enough capacity to weigh what you need to, with maybe a little extra just in case. Readability is a measure of the balance's resolution or division size and is the smallest unit the balance will display. Precision balances typically have higher capacities and a readability between 0.1 grams and 0.001 grams, producing steady readings over a wide range of environmental conditions. Analytical balances are ideal for sensitive results. These balances typically yield readability to 4 decimal places. These balances are more expensive, but more exacting than precision balances. Semi-microbalances, microbalances, and ultra-microbalances are used to weigh the smallest samples and offer readability from 5 to 7 decimal places. Accuracy is the difference between the true value and the measured value, and is not the same as readability. Before purchasing, consult the balance specifications to determine its accuracy. Consider what features you need before purchasing. If you intend to weigh small animals, you should consider a balance with dynamic weighing. These balances are ideal for moving or unstable samples. Other applications, such as parts counting, check weighing, filling, density determination, formulation, and differential weighing, are just some of the features to look for, depending on your application. Consider where your balance will be used. Also consider the sensitivity of an analytical balance. Even very small changes in the environment can affect your readings. Vibrations, such as those that might be caused by traffic outside, can make weighing difficult. To avoid this, choose an anti-vibration work surface or platform. Drafts from ventilation systems or AC units can lead to inaccurate results. Select a balance with a draft shield to make your weighing accurate and easy. Static buildup can cause your measurements to drift in one direction or another. To prevent this, select a balance with a deionizer to remove static charge from your samples. Finally, changes in room temperature can also impact your results. In this scenario, select a balance with automatic recalibration to eliminate temperature variation errors. Consider what accessories you may need. Balances today can be connected to a PC, data printer, an analytical instrument, or a laboratory robot using USB, RS-232, Ethernet, and Bluetooth. Some balances also have density determination kits available as an optional accessory. For many labs requiring GMP or GLP compliance, traceability is essential. Accurate recording of each measurement, as well as who made it on which balance, as well as additional data all tied back to a calibration log, can ensure that any recorded measurement is accurate. Finally, when choosing balances for your lab, consider all the options available. It may be advantageous to select a more sophisticated balance that can perform many functions in your lab. Or perhaps you may consider purchasing several balances, each designed for specific applications. With all the right tools in place, weighing in Linda's lab has never been easier or more accurate. Lab Manager. When we talk science, we mean business. Brought to you by O-House.